Okay. Hi everyone. Uh, I hope I'm audible. So let me just verify that as well quickly. Hi everyone. Yes, I think I'm audible. So yes, welcome back to another day. So today also we'll be solving two problems, and after that I have three problems for you as homework. Now, today will not be covering any specific topic as such. It will be mostly based around strings or ad hoc problems. Uh, uh, Natraj is split by answer is easy. Okay. Anyways, we'll see that if it's really that easy. And yeah, like other than that, uh, so welcome to another session. And today we'll be trying to solve validate IP address as the first problem, and after that we'll be trying to do multiply two strings, and after that I have a few homework questions. Yes, the questions are not very difficult as for today because it might be difficult. It depends on the language that you choose to implement with. If you're choosing Java or Python, it might be very simple, but with C++ it might be a bit challenging, so we'll be continuing with C++ only. And like the same logic will apply to Java and Python as well, but again we can definitely use those languages as well, right? So yeah, like the first problem is validate an IP address. So let's get started with the problem statement. So the problem tells that you are given to write a program to validate an IPv4 address. Now IPv4 address is what it is, decimal, like it is represented by dot decimal notation, where there will be three dots, and there will be four segments. So it will be broken into four segments like this, and each will be ranging from 0 to 255. So each of these, like this one will range from 0 to 255, any value between that. This one will be ranging from 0 to 255, this one will range from 0 to 255, and this one will also range from 0 to 255. So a valid IPv4 address is of the form x1.x2.x3.x4, where 0 less than equal to all of them, x1 x2 x3 x4 less than equals to 255, right? So how here we are considering numbers that only from 0 to 255, and any additional leading zeros will be considered as invalid. So we are only considering numbers from 0 to 255, and additional leading zeros also will be considered as invalid. So your function task is to complete this function is valid, that returns 1 if the IP address is valid, otherwise 0. For example, 222.111.111.111, it is a valid IP address because all the range, it's divided into four segments, 222, 111, 111 and 111, and each of them is within the range 0 to 255. The second one, 5555 dot dot 555, this is obviously invalid one. So and I'm pretty sure like you understand the reason why. So we have to do this, and we have to solve this problem, and the length of the string is within 50, and the expected complexity is order of n, and space is order of 1, right? So let's understand how can we solve this. So the first thing to identify here is what are the conditions, like what are the various types of input that we can get, like why are we even solving this problem, what are the various types of input we can get. We can get something like this, that let's say 256.1.1.0, this is a invalid, right? So this is a invalid IP address. What else can be invalid? We can get something like this, that abc dot 2 dot 2 dot 1, this is also invalid, right? This is also invalid. In fact, ab like this characters can come anywhere, right? Like let's say 255 dot 255 dot abc dot 2, that is also invalid. Or we can also have something like this, that 24 dot 01 dot 12 dot 02, something like this. So this is also invalid because we will not accept leading zeros as well. So this is also invalid. So these are some conditions that will make it invalid. So the idea is, definitely, like we have to separate it out into four parts, right? So if you are using something like Java or Python, right, if you're using something like Java or Python or such languages, JavaScript as well, you can just use the dot split operator, and you can split it across this dot, right? So you will get four segments like 256, 1 1 and 0. You will get an array of these four things. Now you can actually have a is valid segment. You can have a method called is valid segment that will take in a segment and that will tell if the segment is valid. So you can call this is valid segment for all four of them and see if this is a valid IP address, right? It should be true for all of them. So let's discuss a bit about is valid statement. So what we have to do is we definitely first have to split around this. We get an array of four items or somewhere around that, and after that what we will have to do is we have to also, there might be cases like this as well, right? 255.1.2, something like this. So that is also invalid because there should be at least three dots. So this is also invalid, right? So we ideally will have four segments. Let's call it x1, x2, x3, x4. We will call is valid for each of them, and for each of them it should be valid. So how do we write the is valid? That's the question, right? So how do we write the is valid? Let's understand this. So is valid will be what? Is valid will be what? Firstly, everything should be it should be an integer, right? So it should be an integer. It should be in the range 0 to 255. It should be an integer. It should be in the range 0 to 255. Also, what else? It should not have leading zeros. So it should not have leading zeros. So these are the conditions for the segment to be valid. It should be an integer, it should be within this range, and it should not have leading zeros. Anyways, so yeah, we can so once we have this, we can just like verify if the given input is actually valid or not, by taking like by first splitting it into four segments and then by running this is valid on each of these segments, right? Now the question is, how do we split it? Like for Java and Python we can use the dot split method, but for C++ what can we do is we can just use this dot as a delimiter. We can try creating the strings manually, right? We can try creating the parts manually. So first 256 will be opt-in. After that we see a dot, so we'll create a new part. So now we see a dot, so we'll create a new part 1. Then we again see a dot, we'll create a new 1, and after that 0. So like that we can do something, right? So that's the idea. Like we'll use this dot as a delimiter. We'll travel through all the elements one by one, and we'll see like if it's a dot, we will add that part. We have generated one part, so we'll add it to our list of parts, and then we can go ahead for the next part, right? So that's logic. And again, like we have a is valid segment that will check if it's an integer, if it is within the range 0 to 255, and if it should not have any leading zeros. These are the three checks we have to do. So after that it should I think it should be solved. So let's actually go ahead with this. So first thing is splitting it into parts. So let's actually split it into parts. So we'll create a vector string of parts. Vector string of parts. So yes, so what we'll do here is we'll use this as a delimiter. So string part, this empty string, and for int I equals to 0, I less than I equals to 0, I less than s dot size I plus plus. If s of I equals to dot, if s of I equals to dot, in that case part is equals to empty string again, otherwise else part plus equals to s of I, and we will push it into parts. So parts dot push back the part that we have generated till now. So finally we'll be left with the last part. So parts dot push back part. Now first thing, if parts dot size, right? if parts dot size is not equals to 4, then we will return 0. If it is not equals to 4, we will directly return 0. Now if it is equals to 4, we will call is valid part for each of them, right? So let's write this method, bool is valid part. That will take a string part and it will tell if the part is valid or not, right? So first is it should have only so bool is valid initially is true. So for int I equals to 0, I less than part dot size, I plus plus, if part of I less than 0 or part of I is greater than 9, in that case is valid is false. And if not is valid, we will return false directly, or we can return false directly. Let's just return false directly. The second part is it should not have any leading zeros. So it should not have any leading zeros, right? So for int I equals to 0, I less than part dot size, I plus plus, if part of I is equals to 0, in that case is valid will be set to false, else we will break it. If part of I is equals to 0, we'll set this is valid to false, otherwise we'll break it, right? Finally, we are in the last part, so finally it should be within the range 0 to 255. So what can we do? S2I think is there. Int val equals to S2I and part S2I part, and if val is less than 0, actually it will not be less than 0, because anyways like that will not validate this one. So val is greater than 255, is valid equals to false, and if not is valid return false, and finally return is valid. Okay, so we have this is valid. So what we'll do is bool finally answer is equals to int answer equals to 1. So for string part belongs to parts, we'll go through all the parts. If not is valid part answer equals to 0, and finally we'll return answer. So this is the code, else return 0. That should be fine. So let's try to run this. Okay, I have added some wrong characters here, so let me just remove that. Yep, it's expected. So we can actually test it out on a few test cases. So let's say I want to test it out on 255.1.2.ab. let's run this. It should give 0. Okay, it's giving 0. That's fine. Let's test it out on something like 255.255.255.255 and run this. It should give 1. It's giving 1. Let's try 256 somewhere. So let's give 256 here and let's give it a try as well. It's giving 0. Finally let's try something like 0001. That should also give a 0. That should also give a 0, and that's giving a 0. So let's try to submit this now. Okay, it has failed for 0. That's interesting. Let's see why does it fail for 0. 0.0.0.0. Let's try to run this. Oh, for 0.0.0.0, there can be 1 0, right? Yep. So it will fail in this part because here we are setting it to false. um, so let's maintain a count. We cannot do it like this. Count equals to 0, and instead let's do count plus plus. And if count, uh, not exactly. So let's do it something like this, that hey, if it is 0, right, if it is 0, then we can check that if part dot size is greater than 1, in that case is valid is false. Part dot size is greater than 1, in that case is valid is false. And now actually 0.0.0.0 should work. Let's see. Yep, it's working. Let's also verify one more thing, that hey, is this working? 0 1, let's say we give 0 1 here, or maybe we can try 0 0 as well. Yep, it's working. And let's try 0 0 as well. That should also work. Yep, it's working. So let's try to submit now. This should cover all the test cases. And 0 0 dot dot dot. Okay, we are given an input 0 0 dot dot dot. And also one more condition. Yes, we have to add that condition as well. If part dot size is equals to 0, then return false directly. If part dot size is 0, any part size is 0, then it returns false. So we can try this as well. 0 dot 0 dot dot, something like this. Yep. So Java or Python, I can write in Java as well if you want. So let's actually try to write it in Java. It will mostly be the same thing, without like instead of parsing everything, what we can do is we can generate an array of parts. Like only this part will be different, right? Parts equals to, so again I'm not very familiar, but I believe it should be fine. So s dot split, and we can split across the dot, and we have the parts. And after that we can do it in the same way. So we can have a private boolean is valid part, that takes a string part as input and returns true or false. So what we'll do is, for string part belongs to parts, we can see if not is valid part, then we can just return 0, or else will return 1. So we can do it like this as well. And also, if parts dot length is less than 4, is not equals to 4, then also return 0. Parts dot length. And here we can do a same logic, like firstly we can yeah, same logic like will be here, like check for check same thing, like check if uh, greater than 0, all the conditions will be same, right? So you can do it like this as well. This will also work. So anyways, like just try to complete it yourself. I believe like it should be pretty straightforward, nothing that should be like very different. Let me know if any, if you have any doubts with this, with the like I believe it will be very similar to C++ only. Only the corresponding methods will be changing. Let me know if you have any doubts with let's say Java or something. So it just like splitting will be a bit easier than C++. In C++ we are manually splitting it into multiple parts, but in Java we can just use the string split method, and we can get it into multiple parts, and then we can call is valid part for each of them. Now here we can have the checks. We can have the checks. Let's anyways write it down, right? Let's write it down. So what are the things that we look for? If first is parts dot length is equals to 0, then return -1. Sorry, return false. Otherwise, what do we see if it's any character? So for int I equals to 0, I less than parts dot length, I plus plus. If part dot length and part dot length, if part dot get I is less than 0, or part, or is not there, I believe, or part dot get I is greater than 9, in that case also return false, right? These two are over. Now how to check leading zeros? We can just run a loop like this for same thing, right? For int I equals to 0, I less than part dot length. I might be wrong in the syntax somewhere. If part dot get I is equals to 0, if it is equals to 0, else break. If it is equals to 0, and if part dot size, part dot length is greater than is greater than 1, in that case return 0, return false, rather return false, right? And finally integer value. So if integer dot parsing part is greater than 255, sorry 255, return 0, return false. Otherwise you can return true. So there might be some compilation issues. Yes, there are. But part dot length cannot find variable length. Is it a function? Not sure about that, but let's see. Parsing part dot length, or is it size? It should be size here. I think length is valid for strings. Size is for arrays. Part dot length. Part cannot find. What is it called? String part dot at or something. Let's check. Java string methods. Char@. Okay. So we have the char@, I, and also here also char@, I, and here we have char@ as well. Char@. So let's run this. Oh, is it returning a boolean? Okay. Part return false, return false, return true, and size is not there, so it should be length. I hope that this is right. Let's see. Yep. Okay. This is giving one split s dot split this, and if not equals to 0, okay, we have split across this, so let's print out. So system dot out dot println parts. Let's see what are the parts that we are getting, if that's correct or wrong. Mm, okay, anyways, we are getting let's print parts dot length, if it's 4 or not. That should be enough. Another, then we can check what where is it failing. Okay, it's 0 s dot split string parts s dot split. That's interesting. mm, s dot split, it's creating an array. Okay, and we are splitting across dot. That should be it. um, Split should return, right? Yep. Split is this into array of substrings. S dot split dot length maybe. Why are we getting a 0 size here? So maybe a length method is needed. There's nothing called length method. Class string. Okay, so it's not splitting properly. Why is it not? Let's start split this, and system dot out dot println parts dot size, and parts dot size not equals to 4. String cannot be converted. So I was actually taking a string array, right? Why was it not splitting? String parts, and it should be parts dot length. S dot split s dot split, and that should be working. There's something wrong that's happening here. Not sure what's wrong that's happening here, but what we can do is let's check this out. Let's try to check this out. So I'll choose Java here. So I'll take some string IP equals to 127.0.0.1 and string parts equals to ip dot split, and then this, and for system or system dot out dot println parts dot length. Okay, it's not splitting. Not sure why is it not splitting, but it should have split. Anyways, you get the idea, right? Let's not waste time, a lot of time on this. If you're good with Java, like if you are acquainted with Java syntax, you can figure out like why is this not working. That should have worked. I'm not sure what's wrong here, but yeah, like just the same thing, like this part, the logic will be the same thing, right? So we can just skip this for now. We can move to the next question, which is multiply two strings. So we are given two strings, s1 and s2, and we have to multiply them. So we have to calculate their product, and the numbers can be negative as well. So that's the question. So we are given two strings, and we have to multiply them. Now they're given in string format because they can be large, right? So we cannot think about like this, that we can convert them into integers, and then we can uh, uh, then we can calculate their product. That will not work. So we have to multiply strings, two strings, right? So how do we do this? Is basically, okay, so let's rub this everything whatever we've done here. Okay, so how do we multiply two strings? It again comes back to the basic multiplication that we generally learn when we are in, like, let's say class 5, 6 or 7, 8, right? How do we multiply two things, right? So let's say 22, we have 22, and we are multiplying with this, let's say 35 or something like this. What do we do? First of all, we multiply 5 with everything. So 5 to 10, 5 to 10, 11. So we have this. Then we not take anything under this. 3 to 6 and 3 to 6, right? So we have 770 like this. Then we add them up like this. So that's the same logic we'll use here as well. So when we are given two strings, right? When we are given two strings, just consider them as, let's say, let's multiply 235. Let's say this is one string, and we are multiplying it with let's say 11, right? So what we'll do is we are coming with the first, or let's say not 11, let's say 15. So we are coming with the first, the rightmost character, and we are multiplying it. So 5 into 5. So first rightmost character we are starting with. 5 into 5 is 35. 5 into 3, 15 plus 3 is 18. 10 plus 1 is 11, right? Now we will skip this place. Whatever is being generated, we'll skip this place, and we'll start from here. So we'll just add a 0 maybe, right? Instead of skipping, we can just add a 0 here. Next, 5 into 1 is 5. 5 into 1 is 5. 3 into 1 is 3. 2 into 1 is 2. So we have this. Now we can add them up. 5, 9, 10, 13, 4, 3. 3, 4, 3, 5, right? So we'll do it like this. So what we'll do, the logic again, the logic will be, we'll start with the rightmost element. We'll multiply the rightmost element with everything, and this multiplication will be like a single digit with a number. So we can write carry forward and those things. After that, once we are done with this, we are storing the answer in a string, right? We are storing the answer in a string. So once we have generated the answer for this, the first one, what we'll do is, for the next one also, when we generate the answer, we'll also generate the answer. We will just add a few zero to the code again. What we will need here is, we need a way to add two numbers. So let's go to the private section, string add strings. So this will add two strings, so string s1 and string s2, right? This will basically add two strings up. So how do we add two strings, right? Now what we'll do here is we'll start from the rightmost place, so string, and we'll then reverse it, right? So string answer equals to initially empty. So for uh, okay, so first of all, what and we'll also maintain a carry variable, so carry equals to 0 initially, then for, and finally answer dot reverse, return answer dot reverse. We'll just reverse and return that. Okay, first of all, what we'll do is we'll start from the last position, so int I equals to and what we'll do, first of all, we'll pad a few zeros, right? We'll pad a few zeros and then we'll start. So if s1 dot size is less than s2 dot size, we are assuming that s1 has a greater size, is less than s2 dot size. Or what we can do is, yep, we can just reverse these two and then add, then again like reverse the answer, right? So we can just reverse s1, so s1 equals to s1 dot reverse, s2 equals to s2 dot reverse. Now if size if s1 dot size is less than s2 dot size, we can swap them, so swap s1 s2. Then what we'll do is for int I equals to 0, I less than s1 dot size minus s2 dot size, I plus plus s2 plus equals to, we'll pad a few zeros, we'll pad a few zeros, we are padding at the end. Why? Because see, if the number is like, let's say 1 2 3 and we want to pad 2 zeros here, right? So now we have reversed the number, right? So it is 3 to 1 and we'll pad zeros to the end, so that's why we pad zeros to the end, because the numbers are reversed right now. So for, and we'll also yep, for int I equals to 0, I less than s1 dot size, I plus plus, right? I plus plus, what we'll do is int answer equals to int s1I minus 0 plus int s2I minus 0 plus carry, right? Int digit here, digit, let's call it digit. So answer plus equals to str or to string digit modulo 10 and carry equals to digit by 10. To string digit modulo 10 and digit by 10, right? So we have this, and finally we'll reverse the two things. So answer dot reverse. Okay, now we have this. Now we want to multiply the two things, right? We want to multiply them. So let's start with, let's go ahead with that. Okay, so yep, for again like this, there might be size different, actually that doesn't matter, right? The size difference wouldn't matter. So let's generate the answer equals to initially empty string, and maybe we can write a method that will add, but that's fine, like let's just do it right away. So for int I equals to s2 dot size minus 1, I greater than equal to 0, I minus minus, right? I greater than equal to 0, I minus minus, and int carry equals to 0, int carry equals to 0. Now for and int current string current answer equals to empty string, or shall we maybe we'll write a method as well for this, multiply with a digit. So string multiply digit, so string s1 or int and int digit, right? So we'll multiply a digit, and again here also we'll do the same thing. So string answer initially will be empty, and we'll reverse first, right? So int carry initially is 0, and we'll reverse s1 equals to s1 dot reverse, right? We have reversed, and now what we'll do, s1 equals to s1 reverse. Now what we'll do, we'll go for like with one by one. So for int I equals to s1 dot I equals to 0, I less than s1 dot size, I plus plus, int current equals to int s1 of I minus 0 into digit. Now what we'll do, answer plus equals to toString digit modulo 10, and carry, and also plus carry with this digit, and then plus carry should be there also, and carry by equals to 10, right? Also one more thing here, we forgot that answer, like carry is left, right? So if carry is greater than 0, answer plus equals to toString carry, that should also be done. So carry by equals to 10. Now if carry is greater than 0, answer plus equals to toString carry, and finally we can return answer. Carry greater than 0, yes. So I think that will multiply a digit. So what we'll do is current answer is equals to multiply digit s1, and digit is currently s2 of I, and answer dot reverse, sorry, we'll return answer dot reverse. So s2 of I minus 0, okay, that should be the answer, the current answer that we have now. Yep, that should be the current answer that we have, and also whatever answer we have, we will pad a few zeros to that, right? We'll pad a few zeros to that. So num zeros to pad, initially 0, and we'll do plus plus here. So num zeros plus plus. So for int I equals to 0, I less than num zeros, I plus plus, car answer plus equals to 0, right? And then answer equals to answer, what will it be? Answer equals to add strings answer and car answer, and num zeros plus plus. So that many zeros will be padded, and finally we can return answer from here. Okay, so let's see if this is working. So let's try to run this. I think there's a method called reverse answer dot begin, answer dot end. Reverse s1 dot begin, s1 dot end, and reverse s2 dot begin, s2 dot end, and here also reverse s1 dot begin, s1 dot end, and finally here as well reverse answer dot begin, answer dot end. that should be the reverse. Let's see if this is working. In member function, add strings. Let's see C++ reverse string. Reverse reverse is there, right? Reverse method is there, maybe it's not included. Let's see, bits std c++ is there. Member function std string, no match operator equals to. Oh, okay, equals to is not there. Reverse is in place. Okay, reverse doesn't actually return. Reverse does it in place. Okay, that's fine. So we can just reverse here, we can just reverse here, then we can do reverse answer and return answer. Similarly here also we don't have to do this, we can just reverse answer and finally return answer. Yes, so let's try this. Okay, 33 2 and we have 6 2. 33 2, so it will come here. Okay, 33 2, and also one more thing we have, but again like that, these are positive numbers. So 33 2, we have 6 hyphen 2. Let's see why. So I equals to st dot size, so here carry is 0. Carry is not needed actually. So multiply digit 66 and 2. So let's print out here what do we have. So C out S1 and digit, it should be 66 and 2 handle. Let's see. Yes. 33 and 2. Okay, 33 and 2, that's fine. Answer equals to 0, and let's see what is the answer finally here. So C out answer handle. 33 and 2, and we are getting an answer of 22. That's interesting. So reverse s1, one second, reverse. Okay, reverse s1 dot begin, s1 dot end, it's reversed. Then I equals to 0, I less than r size, int s of I, s1 of I minus 0 into digit plus carry. Okay, answer equals to plus equals to 2 string digit modulo 10. Answer plus equals to 2 string digit modulo 10, and yes, digit, not digit modulo 10, rather current modulo 10, current modulo 10, and carry by equals to, and current by carry equals to current by 10. So that should be there. Okay, 66 here, from here we are getting 66. Okay, this is giving 66. Now this is causing problem. Num zeros, I plus plus, that should be 0. Add strings, answer and current answer. Answer is empty, current answer is 66. So let's print here C out answer and current answer. C out S1 and S2, sorry, S1 S2 handle. Let's print these two. Yes, we have 66 and empty, that's fine. Answer equals to this, and then carry equals to 0. We reverse both of them. S1 dot size less than swapping, we are done with swapping, so S1 S2 is then 66 comma empty, and then S1 dot size minus S2 dot size, that's 2, so S2 will be 0 0. right? So let's see here, see out s1 s2, s2 enter. So let's see out s1 and s2. So we have 66 and 0, 66 and 0, why 0? S1 dot size minus S2 dot size. So S1 dot size is I equals to 0, I less than 2, 0, 1. So S1 dot size should be, S1 dot size should be 2. It should be 2, right? Why did it not? See out S1 dot size, S2 dot size. It should be 2 and 0. That should be the sizes. 2 and 0, yes. So I equals to 0, I less than s1 dot size minus s2 dot size. 2 minus 0, I less than 2, I equals to 0, I equals to 1, s2 plus equals to 0. Okay, s2 plus equals to 0. So there should be two, there should be two zeros, and here also we have made a mistake. Digit by 10 is okay, I think. Digit s1 I minus 0 plus s2 I minus 0. Okay, I less than s1 dot size minus s2 dot size I plus plus. See out here slash n, and s2 plus equals to, oh okay, s2 is dynamic, it's changing dynamically, right? So int difference equals to, got it. So what exactly happened here, I'll tell you. S1 dot size minus s2 dot size it should be, but what happened here is s2, after first iteration the size of s2 changed to 1, right? So it will be 2 minus 1. So this also, this condition also changed dynamically. So that's why s2 plus equals to 0, we had one of them. Now we can do this 66 and there, that's fine. So we have the answer finally. Okay, this will work for positive numbers only for now. Yep. So this is working for the this is working for positive numbers. Now how to handle negative numbers? So if, so bool is neg, right, is neg equals to false initially. Now if s1 of 0 is equals to minus, or and s2, s1 of 0 equals to minus, or s2 of 0 is equals to minus, and if both of them are not minus, so if s1 of 0 is equals to minus, and s2 of 0 equals to minus, if both of them are minus, then we do nothing, then we should do nothing. So is neg is false, else is neg is true, is neg is true. Or what can we do here? Instead of like this, what we can do is, if s1 of 0 is equals to minus, is neg equals to true, and s1 equals to s1 dot substring 1, we'll take the first. Now if s2 of 0 is equals to minus, so is neg will be the not of is neg, whatever is there, and s2 equals to s2 dot sub str 1, and if is neg return minus plus answer. So that should work. Let's see. Okay, it's working. Let's give some another 33 minus 11. So let's see if this is working. minus 363. So let's try to submit this now. Okay, for 0 and so